Okay. How's it going this morning? Remember Friday we started talking about circle geometry. So there's two main ideas that you need to get out of Friday. That is, you have a central angle, the measure of the angle is equal to the measure of the arc. And if you have an inscribed angle, the measure of the angle is half the measure of the arc. Any questions on those two main ideas? So Wednesday this week, there'll be a quiz, and it'll just be on those two things. So central angle equals its arc, and the inscribed angle is half its arc. That would be Wednesday's quiz. Okay? All right, so we're moving on. The next thing we're going to talk about is more segments and circles. This time it's the intersection of two chords. And this time I'll just jump right in and tell you what the fact is. We'll do some examples, then I'll explain why afterwards. Okay? So here's the fact. Two chords intersect inside a circle. Then the product of the segments, one chord, product of the segments of one chord equals the product of the segments of the other chord. Okay, so pictures, if I have circle, two chords intersecting inside it, so something like this, for example. Each chord is split up into two pieces, right? Like this chord right here is split up into two pieces. Let's call them like A and B. And this other chord is also split up into two pieces. Let's call them like C and D. So what this fact is saying is A times B equals C times D. The product of the segments of one chord, A times B, equals the product of the segments of the other chord, C times D. That's what this fact is saying. You have two chords intersecting inside a circle, and the product of the segments of one chord, product of the segments of the other chord. Any questions so far? So this is super easy to use. They're going to give you 3 out of 4 lengths. You just have to find the missing length. So if I have like this, chords intersecting inside a circle like that. And let's suppose the side lengths are 6 and 4 and 3, and we're trying to find the length of this piece right here. You just set up the equation. That's all there is to it. This is just going to be 3 times x equals 4 times 6. Which is super easy to solve, right? So you have 3x equals 24. So x is 8. Okay. About 2 chords intersecting inside a circle like this. say the lengths are 6, 10, and 12. We're trying to find this piece. Product of the segments of one chord equals the product of the segments of the other chord. So you have 12 times x equals 10 times 6. So 12x equals 60. Divide by 12, and x is 5. That's pretty easy, right? So let's talk about why this fact is true. Why? So let's draw a picture here. Two chords intersecting inside the circle. Yeah. And let's label the pieces A, B, C, D. But at the same time, let's also label the points. So let's label these points like U, B, W, X, and Y. So I can talk about the points. In addition, I'm going to draw some extra line segments. Like I'm going to draw this chord UB, and I'm going to draw this chord XW. So if you think about it, what we talked about the other day was this angle right here has to be the same measure as this angle right here. Why is that true? Why is this angle the same as this angle? This is directly from Friday, so why is it true?
Is it because of the inscribed angles?
Yeah, these are both inscribed angles, so they're each half their intercepted arc. How does that make these equal? Yeah, their intercepted arc in both cases is ux, right? So this angle is half of ux, whatever that may be. This angle is also half of ux, whatever that may be. So they have to be equal to each other. There was one of the facts at the end of the notes the other day. It said if you have two inscribed angles that both intersect the same arc, then they have to be congruent to each other, right? For the same reason, this angle right here is equal to this angle, right? Because these are both inscribed angles, which are each half of BW. This is half of BW. This is also half of BW. So they're equal to each other. These angles are also equal to each other. Why are they equal to each other? Vertical angles. So you have two triangles where all the angles match up. In fact, these two triangles are similar triangles, right? If you have two triangles where all the angles are the same, then the triangles are definitely the same shape, right? They're similar to each other. So I could say something like by angle, 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 right? By angle, 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 triangle BWY is similar to triangle. Now remember, the order of the letters matters, right? But BWY, right? XWY, I should say. XWY. All right, so the order of the letters matters. So if I say triangle XWY, what would have to be the order of the letters in the other triangle?
UVY.
Yeah, UVY. Similar to triangle UVY. And if you have similar polygons, that means the sides are proportional. So sides are proportional. Which means that C over A equals B over D. That's definitely true, right? Those are the sides that go together, right? In these triangles, the C and the A are like the corresponding sides. And the B and the D are also corresponding sides, right? But then you could just cross multiply this and get exactly what we're saying is true. Cross multiply, and you get A times B equals C times D, which is exactly what we were trying to show in the beginning. The product of the segments of one chord, A times B, equals the product of the segments of the other chord, C times D. Does everybody understand why that's true? Okay, so the Delta Math homework assignments are really just like this. They're going to give you 3 out of the 4 segment lengths. And you just have to find the 4th one by setting up the equation, multiplying, dividing, and getting the answer. That's it. Any questions? All right, so it's on Delta Math. It's just called intersection of chords.